When's our first test going to be?
Oh, it's an excellent question. We should always know the answer to that question.
Yeah.
I try to be as organized as I possibly can. Look at all those pictures of books. That's fun. Right here is our schedule. So I've been sticking closely to this. I don't know if I get credit for that. Do I get credit for, is that a credit type of thing? Right. So our first exam is scheduled for Tuesday, the 28th. What are we today? We're like right here, right? So it's several weeks away.
Okay.
It's only going to be on chapter 3. We are just now, we started talking about elastic strain transformation and we're going to do curved beams. So next week is really curved beams, context. Actually, context stress might be that's a short thing. It's just that I did, okay. And then deflection and superposition, and we'll start using FEA right here. So so right there is where my plan is for it. And we'll use the review session that's right here on the 24th. That's going to be the exam review session. We might get a different room so that we can make it longer, because I think more than an hour is needed. I won't pull any punches. People bomb this first exam. I mean, just historically. I created this review session because I don't know how else to address this problem that I know exists, and I really want to. I'm very highly motivated to fix what I see as something that's broken. So we got to work together to try to do that. And the number one way to do that is to solve problems. So even looking at that, if I haven't mentioned this, sometimes I forget, but you can see that here is practice problems. Practice for the exam right here. There's a bunch of problems in here. I even have the solutions to them as videos right here. I had been holding back on the solutions to them.
Yeah, don't post them.
Because I really don't want people to be tempted to look at the solution to them, but already to have half of them already done in terms of videos. So I don't know. I go back and forth. For the exam review session, I usually just do kind of similar things to this, but like maybe stuff that's more tailored to the exam. I will go over the review problems. I'll do anything anybody wants to try to work on. I forgot to bring some paper, so I think I have to go get some paper. So talk amongst yourselves. Just remember you're being recorded. It doesn't matter. I just want to. I'll just get a. It feels good to have a nice fresh tea. Okay, so for the stuff that I was thinking about today, but of course it's always up to you what you want to, what you'd like to put on, work on today. But I did bring a mechanics and materials book with me. I was going to randomly pick out a problem and try to see if we can work through it together. What would you like to do though? You're talking about. Okay.
Kind of those 3 circle, Mohr Circle.
Okay.
Ones.
Mohr Circle, sounds good.
And then like the beam where they have the discs that are rotating, that's kind of still throwing me off a little.
Oh, you mean like a loaded shaft? Okay, that's excellent. I did grade some of the homework 2. I should be getting to that on Wednesdays instead of waiting till Fridays. But you should really look over that when I get it finished. Let's do a Mohr Circle, yeah. So, let's see, is this upside down? No, it's okay. Let me see. I'll find a problem. And this is something, I'm doing this with a purpose in mind. I'm randomly looking for where that part is in Beard-Johnston, this is just an awesome, by the way, this is an awesome textbook right here. Dave Mazur, I know Dave Mazur. Name dropper, that's what I am. Okay, let's see. It looks like here is a Mohr Circle problem. And here's where they actually talk about 3D Mohr Circle. So isn't that something else? So let's see, let's give us any more problems. They got problems in the back here. Let's check them out. There you go. Here's one right there. So they say, now they're trying to go better. They're trying to go for determine the value for which the maximum shearing stress is. Oh, they're going backwards in a problem like that. We don't need to do that. Let's do a different one here. State the place shows occurs in a machine component made of steel with this using the maximum. Oh no, okay, that's chapter 5 stuff for us. So let's go a little earlier in here and just pick out one. We could actually just make up values if we wanted to, but yeah, for whatever reason they're doing something in some of these problems where they're working backwards, which we don't need to do. All right, so here's one right here. Just because I don't feel very creative today. This is F21 ME370 review session 3. What is today? 9/10/21? Oh, sure, that's off. Sure. Why don't you leave it open just a crack in case somebody wants to join us? So we want to feel as though we're welcoming. For the state of stress shown, determine the maximum shearing stress when Z. Oh, this is interesting. Okay, so they're doing the 3D Mohr Circle thing right here, and they're saying these 3 different scenarios. Okay, that's good. I like that. So they've decided that we have this one right here, and they decided to give us these weird looking figure right here, right? Well, they decided to make it that way. 100 megapascals, and here is 84 megapascals. And they also said they wanted to say for the A part of this is the Z direction 0, B Z direction is going to be equal to 60 megapascals, by which they mean tension when they say positive. And then C, 60 megapascals compression. And this is Johnston 7.70. You do that because honestly, I keep these things and go back and like, where did I get that from? All right, so we'll use the handy dandy ruler. Why not? And if I was going to, first off, I'll make a nice straight line, and we got 100 as their largest one right here, so I don't want to use the whole page for 100. Let me go like this. I'll go 20, 40, 60, 80, 100 right there. I think I got that right. I didn't make this very perpendicular to each other, so there's 20, 40, 60, 20, 40, 60. I think we'll be okay there. Although they have 80, don't they? Yeah, I might have messed up by making that so low. Yeah, we'll just do our best. Yeah, because this is 84. Let's see what happens. All right, on this first face right here, we want to plot that. So we take 30, which is going to be like right there, right? And 84, and the 84 is going that direction. So onto this one, let's see, here's, as I mentioned, I should have probably gone out a little before. Let me see, 20, 40, 60, 80, 100. So 84 is like right there. So, I'm sorry. Right there? Is that okay? Okay, and then on this other face over here, we got 184, right? So here was 20, 40, 60, 80, 100, and 20, 40, 60, 80, 100. That's kind of ridiculous right there at that point, but okay. Oh, actually, I probably did that kind of bad, right? So it should actually be like, this actually be a little upper, right? Because halfway through would be 90, so we probably go like right there, yeah. So like that this might be a little better, I don't know. And this one over here is going to go and be up here somewhere. There would be 90, so maybe like right there. So yes, so this should be 184, and this is 100 and negative 84. Not 100. That should be 30. Thank you. Keep me honest. Yeah. And I guess I can attempt to use my. It's a little. It's kind of a better one than some of the others, but this is like loose right here. It really kind of messes with me. And what's 100 plus 30 is 130, and half of that should be what, 65? So I should have landed, the center should land at 65, so I can kind of show you how bad my improvised graph paper here. Didn't do a great job, but here. So there you go. We made a Mohr circle. And we could extend this thing out here. I really should have probably used some engineering paper, right? That would have been. But we go for the center of this thing first. The center of these points is going to be 100 plus 30 divided by 2. And let's see. So, we already said that on our heads, right? 65? Yeah. Now the radius of this, okay, so we got to pick a spot for the radius. Here's C. Let's get a label of that. I'm going to pick this guy right there as my radius. So this length right there is going to be the center, 65, minus 30. That's going to be that length right there. And then it's just going to be this high, which is 84 squared. So 65 minus 30. I could do that in my head. It's 35? Okay. You have to double check for me though. John, math. All right, so I get that that's going to be 91. So my sigma 1, sometimes I call it, well, maybe I'll call it sigma A. We'll call it sigma A. We'll keep doing that here just for a second because I might want to mess with that right here. Is going to be C plus R. So whatever that 65 plus 91 is 156 megapascals.
That's going to be tension for sure. So that's that guy over
I
here.
just have a question, quick.
Yep.
If you found the radius for the other side, the center point would be 100 minus 65?
Yes.
Okay.
Yeah, absolutely. Yeah, this leg would be 100 minus the 65.
Okay.
You do either one, doesn't really matter. C minus R, is that still on the page? Yeah. So we have 65 minus 91. And I get a negative 26. And just to make sure that we are always saying that's compression, right? You see I wrote it again, so I didn't make it negative in compression. Now we have to do the 3D Mohr circle aspect of this, right? Now that we got the principal stresses, we also know that this right here is going to be tau. It's this in the first case up here. This ends up being sigma 0 right here is one of the principal stresses. So we have that guy, and then, wow, actually, feeling pretty cocky. No, wasn't great. Started off, it felt pretty good when I got to right on there. I started feeling like my circle skills were doing okay, but then it all fell apart. So that would be this first answer right here. Now we have another one here where we have, okay, so 60. What if 60 was something that was happening in the z direction? And so probably the thing we care the most about when it comes to what's going to happen here is what the absolute maximum shear is going to be. And in this situation, it's the first one, it's going to be this guy right here, abs max. And that's just equal to the radius. That's going to equal to 91. But now we have these what if things for B and C. So I'll just draw them below. All right, so we have all of the same stuff. The principal stresses are still going to remain the same, these A and this B. Now let me see, I'll draw it kind of a smaller version of the thing. So now we're going to say, right here, and I'm just going to try to mimic what we had there, something like that. So I guess I'll use another piece of paper here for the other one. And so we still have this guy and this guy. But now, if the other principal stress is 60, it would look pretty close to being like right there. I'm just estimating from like, this was like, the center of this was 65, but now this is like right here. So we would have a Mohr circle, if it'll let me do this. Let's see. I'm gonna do my, oh, it's doing that thing where, I hate that. No. I'm eyeballing this. Eyeball engineering. Ah, I messed it all up. Let's pretend it looked okay. We'll do pretend. All right, so now this is sigma 1, this is sigma 2, and this is sigma 3. Sigma 2 would be that 60 megapascals in tension, right? So this guy was the 156, and he would be the 26, right? Yeah, 26. With these compression over here. Not any big difference. And the tau abs max still the same. But now for this other thing that they were talking about, I'm sorry. The other situation where we have 60 is the out of play. That's compression, right? You can't quite see it. Let me see if I'll go. I can't go up any higher. Yes, sir. Okay, good. Then tell me.
And then the 60 from this new part.
Yep. Yeah. Yeah, they're just coming to, yeah, like, so like the typical situation that we're going to almost always have, except for when we're dealing with a stress element that's on the inside surface.
I understand what's happening now.
Yeah, okay. Okay. I just picked out a problem and I said, oh, hey, look, they gave you some more scenarios. And
You chose to use B, or no?
what's that?
You chose to use the 60 megapascals in tension? No.
In this one right down here,
And then the first one uses,
uses A.
so we're going to do a third one.
I'm going to do a third one because I thought, oh, that's an interesting one because that is a situation where, I mean, that could possibly exist. I don't know where it is necessarily, but I just want to, like, you know, we don't have to be, let's see, I think I'll leave enough space for myself. But let's say, oh, eyeballing still. So let's say that this is the situation there where we have, this is still going to be the 23 that we got, oh no, 26 right there. And this is the 156. But now all of a sudden we have another principal stress over here that's going to be 60. Right? So now we'll have a principal stress. Whoops, that's dumb. Something like that. And then eyeball this. See if I can. It's close. All right. All right. So then our principal stresses are going to be, this will be equal sigma 1. This will be sigma 2. And this is sigma 3. Right? But sigma 3 is this. So tau abs max is by definition sigma 1 minus sigma 3 over 2. Sigma 1 is 156. Sigma 3 is negative 60 divided by 2. So 156 and 60. I think I did that wrong. 156 and 60, there you go, is going to be 108 megapascals because he's going to be up here. Does that like help at all to sort it out?
Yeah.
And what's good with this is how my roommate and I got A's in engineering problems. Is that, well, first off, he was a very competitive guy. So we'd make like a competition out of the thing. We'd go to an empty classroom at night as they left the buildings unlocked. I don't think they probably do that anymore. And they would chalkboards. We'd have some chalk, and he'd say, okay, we're going to do this problem, and then we'd race to see who could do it, and we have the answer in the back, right? And okay, well, you know, you don't have the solution, but you have the answer, and then we would see like who could get it, right? And kind of make it a competition, and then like the person who could get it that got it right, if the other person didn't, we try to explain it to the other person, right? And then we'd argue about it. He really liked to argue. And between the two things right there, between the two of us, and by the way, I wouldn't say we were best of friends. We were probably friends later in life. But we definitely pushed each other. So I'll say 770. All right, so it's not giving me what I want. Oh no, okay, no, the problem asked for the absolute maximum shear. Okay, yeah, so it's the correct answer. Yeah, they had 91, 91, and 108. So 91 was our radius in both of the first two, and 108 was the answer. So we got the right answer.
So you would have to feel free to find that only when the third stress is 60 megapascals in compression,
Yep.
that gives you
Yep.
the absolute max.
Exactly. And so the absolute max is the radius in the other two situations. And I got to tell you, this is how I think the human brain, in a simplistic way, kind of formulates things. We kind of make a path through our brain to try to connect things, and we make connections. Everybody does it similar ways, but people have their own little things that help you to make those connections as we're trying to wind through the path. And you're kind of like constructing this yourself. They call it the constructivist viewpoint of education, right? That you kind of have to build it yourself. You have to do it yourself. I can't do it for you. But by working through a problem and struggling through it and answering your own questions, you're able to like make that. And then when you're on a test, you're just riding that path. So while you're working through a problem, you're carving this path for yourself. And it's really the struggle that makes it exist, not the observation of somebody else struggling. And so, you know, I keep hitting it home, that you have to do this yourself. So coming up with a fresh problem. And then also, you know, the fact that Andy Busk and I would like, you know, we would challenge each other, right? And it's the challenge that helps you to and, you know, boy, doesn't it feel good when you just know it. You know what you did the right, and it feels terrible when you thought you did. But all right, so let's take a look at a shaft problem. They have shaft problems in here. Sometimes they're hard to find, so I don't want to waste too much time flipping. But I think I saw one right there, and we could invent some of this ourselves. This one might be too hard. Yeah, but here's one that's a little easier, or here's one a little harder. Which one would you like to do? Do the easier one here.
We haven't done connecting ones yet. I mean, we did them in dancing materials, but not here, right?
Not in here yet. Yeah, we haven't drawn what that should look like, but I could teach you what that would look like, right? Depending on which one's driving, which one right here. But so we're going to do this guy right here, which is problem 820.
I can't write on the left. I used to just not even write on the back of the keyboard.
Let's see. I'll kind of try to be a good role model here, because I'm seeing some people that need to, you know, do a little bit more careful drawing. I'm not liking my own drawing right now, by the way, so I kind of psyched myself out, I think. Yeah, that was lame. That was awful. Don't be like me, kids. Be better. So. I think for both of you, I put a note on their homework to ask you to please do a better job scanning. I would recommend a different app than what you're using. I don't know what you're using, but I know. Yeah, I mean.
Like the quality, or?
It's just, I also attached, and I probably do this with most people, attached mine. Said, hey, I just used the scanning. I used my iPhone and I just scanned it with the thing and was able to get nice crisp lines, right? That I could, like, you could see, there's no doubt of what it is, you know, just compare the two and try to mimic the same thing. Okay, so I spent too much time making this thing up, but it would really be helpful to me because it's the interface that I use to grade for the thing does a little bit of it, the resolution gets a little bit reduced on that. And it's just so that I had to, and if I have to zoom in, I can't post a note onto the thing. So it's like I gotta zoom in and then zoom out and then zoom in. It becomes, it already takes me forever to do. So, okay, so this is B, and this is D, and these distances right here. Oh, one more. It's going to be 7 inches. I'm just going to write 7. They're all 7. Use a little inch symbol. This one is got a radius of 4. And this one has a radius of 6. And this one has a radius of 4. Anything else? This is 500 pounds, 500 pounds, and P. Good, they left one out. And they say that the shaft diameter, they tell us this, no, they want us to determine the shaft diameter in this problem. So let's work backwards in this. This is problem 820. I don't know if they have the solution to this. I do have the solution manual to this book somewhere.
Probably not.
Sometimes I'm just looking right here. I see some that they kind of have random amounts of problems. I see even. No, they do 1.578. D is equal to 1.578 inches would be the answer. But they said that the shear allowable was 8 KSI. All right, so they're actually using maximum shear stress theory as part of this right here. But so we have something to work backwards to for what we've been doing. We haven't done the design aspect. We're working backwards. So all right. So the first thing that we want to do is figure out what that unknown force is going to be. So let's draw it down the center here. All right, so this guy is P, and we have to draw them on top of each other because they're the same diameters right here. Right, there's 4 inches and 4 inches in radius. So we'll call it 1,000, right? Because they're laying on top of each other. And in the real world, it would probably be smart to, just label these R. Okay, and did they give us they decided this is X. All right, good man. I agree. That should be X, X should be Z, and it should be Y right there. So this is the RZ, and this is like an R, Y. And they're just space holders because we don't know the thing. But we do the summation of the moments about X is equal to 0. And this radius is 4, and this radius is 6 inches. So we just say 1,000 times 4 minus P times 6 is equal to 0, and P should be 666.6. And we're in pounds, sure. And while we're at it, it might be smart to figure out what the torque is going to be. Now, this will be a little bit of an interesting thing here, so I'm trying to think my way through. I think regardless of what you have, yeah, that's going to be true. Whether you split it here or you split it there, it's going to have the same torque. Because, all we really ever need to do is just cut it someplace and try, but we have the 500 right here. And so there's going to be a torque that goes this way, right in there. So that's me cutting it right there in between the two. They probably look the same. So moment about the X. So we go 500 times 4 minus T equals, and T is going to be I should do that in my head, right? 2,000? 2,000 inch-pounds. And then if you did the same thing over to this one right here, it would be really the same diagram, basically, right? You'd just be looking up magically through the gear or pulley or whatever this thing happens to be. All right, so we needed the torque, we need this. Okay, we're going to go. Now let's do two diagrams. Go ahead. Oh, you're yawning. Okay. Two diagrams of this thing. Gotta check our time, right? You needed to go at early, right?
I gotta go to the club there. I'm going.
Oh yeah, it's important. I agree with that. I see what you mean.
All the other ASM Viewpoint numbers, also Viewpoint numbers, as far as, it's like always you only want to ask, right? Ever since we.
They ever pick on you? Do the kids pick on each other? I heard maybe it's just the Westbrook because we have a shitty school system. But they used to. I was very upset when my kids used the first phrase that these kids are a bunch of tryhards. Did the people call you? Did they ever say, well, what a bunch of tryhards? And I'm like, why aren't you a bunch of tryhards? Says your father. But then I asked my quasi-nephews. They're not really. He's my best friend from high school. I still hang out with them. They live in North Carolina. But I asked their kids. They call me Uncle Ted, but I'm not really their uncle. And I asked them if they knew what the tryhards were. And I said, yep, yo, man, those guys are, and I knew we had a bunch of those in our school. And it's kind of funny because he was the valedictorian of our high school and never made a B in his life. He's a pulmonologist. And his kids are calling other kids tryhards. It was hilarious to me. You had to be there. Because he was definitely the original tryhard. So let's say we said this was 666.7 pounds, that guy right there, and I didn't leave enough room in between there. Unfortunately, because of symmetry right here, it's really, really easy to get the reactions. But I found a number of people not getting the correct reactions, and it's like a really, really important skill. So if that happens to be you, make sure that you're testing yourself and you're figuring out why you got it wrong, what like maybe misconception or maybe just silly mistake that you made, and try to fix that. Yeah, the concept should have gone away at this point, right? Yeah. Well, you hope. Well, the crazy little boys' school I went to, it wasn't. There were women there too, but it was mostly men. It's really sort of like Lord of the Flies, and to some extent, and people would get angry when they found out that somebody had really aced an exam, because then it bust the curve. Right? Everybody's relying on a curve, and it's like, who the hell did that? Let's go try to find the person that made the high grade. You're letting everybody down, you know. That's not fair to everyone else that you do so well on an exam. It doesn't make a whole lot of sense. You really are. How self-centered are you? We had all kinds of things where we would have we'd have to demonstrate class unity as freshmen and do like little spirit events and that kind of thing to try to earn the privileges. Like some of it with soda privileges, there was also flanking privileges because you had to square every corner when you're inside going down the hall. You had to walk 6 inches away from the wall, which is referred to as a bulkhead because everything's a fake ship. And we had to, so if you're going someplace and you have to turn, you have to do that everywhere. But if you do enough class unity events, several months into there, you're allowed to go like this. It was, it made things a lot faster. You weren't allowed to drink soda, but then you get soda privileges, all kinds of things. Oh yeah. Telephone privileges, all kinds of things. But you had to use class unity, and it was not being a good class unity person by doing well on the exam because you hurt your classmates. That was the stupid logic. But anyway, we'll go ahead and say that we know that's 500 pounds and that's 500 pounds. And that this is 333.3 and this is 333.3. But make sure that you can do that. So this is interesting because it goes right here. So this is coming up. We know that RAY is equal to 500 pounds. It just has to be, right? There's no way around it. So it comes up 500, but now it goes 0 all the way through. And then it comes down 500. And then back up to 0, right? Everybody see the logic? So for this, it's going to come up, it ramps up to right here, and this distance is 7,777. So it's 500 times 7, which is 3,500. We'll put the V and M that are there, and that this is a pound, and this is an inch pound. So you can see what happens here, right? So you ramp up here to this, and then nothing happens, so it stays constant all the way along. And then this right here is a negative area, so it brings it back down. So it's pretty easy to figure out that it's 3,500 at each of these spots right here. But now on here, this one goes down 333, so we know that this is 333.3. But then it goes up 666 this direction, so this is a negative 333.3. Yeah, because Z is, because we're looking down upon this one. The Z is pointing that direction. And so we're going to get a slope. So this is going to be 333.333 times 7. You get 2,333. But the more important one, we're going to have 3, it's going to be times 2, right? Or 333.333 times 14. So we get 4.
Thank you.
You're welcome. Best of luck. Recruit well if that's where you're going. So you can see that we suspect there's 3 separate spots where there could be the maximum stress. So, but right here has to be the worst one right there, right? So the maximum moment is going to be 3,500 squared plus our 4,667 squared. So let me see, that's already in the calculator, so I'll square U2 and 3,500, add them together, square root them, we get 5,833 0.33333333 inch pounds. About 10 minutes from now. Talk to you soon. And okay, so we have I pi over 64. Let's use the 1.578 answer squared. 1.578 squared. Where did pi go? Pi times 64 divided. Well, not squared. 1.5784. And we're going to use that guy. And then take pi times them. And 64 divided. And I get 3.044 e minus 1 inches fourthed. And so J is just 2 times that. So we get 0.6087 inches fourthed. And then, so the stress is going to be MC over I. So we'll take our 5833 and go 1.578 divided by 2 and divided by 0.3044 equals 5833, 1.578, 2 divided times 0.3044 divided. I say that I get 15.12 KSI. And then tau, TR over J. And we found previously that we had 2,000 and 1.578 over 2, 0.6087. So we go 1.578 divided by 2, boom, 2,000 times 0.6087 divided. I get only 2.592 KSI. So now we're hoping we have a Mohr circle that we will make here, where it doesn't matter which side we go on here. We'll say that the center is going to be 15.12 divided by 2. So 7.5 looks like 60. And R, this one is the easiest one. Didn't do a very good job of making a little bracket thingy. So there's 7.560 is one of the legs, and the other leg is 2.592. And I think this should come out to 8. If I did it correctly, this should come out to 8. The moment of truth. Drum roll, please. Boom. Yes. 7.992 KSI. So that is satisfaction.
So that's the tau max. We did tau level.
Yes.
Okay.
But hopefully this might inspire someone to attempt to do this thing that we just did. Look at the book, look at the problem in the back.
What's the arrangement? How to solve it?
And just, well, I mean, in this case, I flipped the arrangement, but it might be a problem in Shigley. Shigley has the answers for some selected problems. just test yourself, push yourself, and by way of doing that, you're carving that path. You really are. And it's the most efficient way to study. It really is. It might seem like, oh man, that's just going to be, that seems so hard, so much extra work, but it's the bang for the buck that you get out of just working through problems and pushing yourself, and not only that, but building up the confidence. If you're not a good test taker, and lots of people aren't, right? Some people more so than others. Getting that amount of confidence, that self-assuredness, because you were able to get the same answers the back of the book.
You're not questioning whether
Yeah, you got it. You got this nailed. You got this down, right? But you're also, exposing your weaknesses too. So if you don't get it, because you would come to me, and I'll often say, for me, truth be told, I don't think it meant. I think I can say this safely, that my opinion of you will not affect your grade. But that's not true with every professor, okay? So doing this in every single class, you come to a professor with your worked out thing and you couldn't get the answer, and they'll be like, oh my God, yes, thank you, Lord. Thank you for giving me a student who gives a shit enough to actually have tried this on their own before they came to me. Yes. Once again, if you do that, I'll be impressed, but that won't change. But at the same time, like at the end of the semester, we have, I turn off all this is being recorded. But I think it's true on every professor. We get to we have all these numbers. We've collected all these numbers right here. And then I look at you. Okay, here's what your overall average is. That's a C+. But then I see, oh, look, on the final exam. Ooh, you made a B+. Oh, okay. You turned every homework assignment in. Okay. You did bad on test 1. Damn. Came to me, asked for help. You know what? Suddenly, all this average, just one more second, Frank. Suddenly, this average looks a lot like a B plus student to me instead of a C plus, or maybe a B. You know what I'm saying? Because, yeah, well, maybe I'm going to ignore him at the first exam.
I'm definitely starting to get like the methods down. Like before, I was just having like little trouble with